Okay.
Now you can see a moment if a force is not applied on the center of the connection, it will produce a moment, right? A moment. We should analyze it as this equation, as this method, right? And we can analyze. We can find this one. This top, it depends on this f. If the f is applied on near to the 5, you can find the 5 is inverse, right? Because it depends on the direction of the moment. Clear? Clear. Now we come back. We can see a case like this one. We normally use this equation to calculate. Use this equation to calculate the maximum normal force for the boat. Maximum force for the boat. The N is what? Not right.
What?
The M?
N.
Oh, you said M. What you said M?
The N
M is the force.
is the force, no force applied on here. The moment is equal to the F point the E, right? The moment. And this one N means the number of the boat. Number of the boat. And this one is the moment applied on this one, the force. Do you know the equation? Can you memorize the equation? This equation. You can see this one. For moment applied on here, we can use this moment for each point to the centers, and the moment over the distance y1, y2, y3, have the ratio the same. Then we combine this equation, we can get how to calculate the moment, and you can see here. You can see here. Then we can use this equation to get this force in the dangerous boat. Now we can see to do the case. You can see found a boat M20 applied on here. Try to think about how to do this case. Boat distance is 100 millimeters. And the force 200 applied on here equal to 8. Is the distance to the center equal to the 80 millimeters. Can we check the connection is dangerous or not dangerous? Anyone want to try, or I directly show you the answers? You should try it by yourself.
Yeah.
Think about it. So the first step is what? First step is what? We check the tension capacities for each boat. We get this just to show you the logic. You don't need it. You should understand it. And when you meet this, when you face some problem as this case, you can directly use this method. Okay. Firstly, to calculate the tensional capacity of the boat, we can use. And then we calculate the larger tension. This is the N. I will explain each details for in this page. The AE. The AE is what? Yes, this is what we check from the code, right? And now we get the tensional capacity of the boat. We analyze the first boat, it will be dangerous, right? And now we calculate the maximum normal stress in this one. This one will be correspond to the maximum normal stress. So the N equal to 200 kilonewtons. Here you can find the 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 volts right here. We can get a single volt applied directly, only applied by this force, right?
Okay.
And now we can calculate the moment. The 200 is the force P. And the diameter, this is the 80. Right? We calculate the moment. Calculate the moment. And do you memorize the what? For the moment, each bolt distance is 100. Each bolt distance is 100. So means this is centered, right? 100. Here 100 means this is have 200 to the center, right? 200 to the center. And they have two lines. It's two lines. 1, 2, right? They have two lines, and we point the I squares. Okay. So what's the question?
You said the diameter is 8.
No, distance.
Because there on the question, the 80 is the
It
centricity.
is the first the bolt for this one. Oh, this is the force to the center is 80. The force, the moment. This case is to calculate the moment m equal to F point the E. Know that?
So the 80 is the eccentricity.
Yes, that's not sleeping. This one. Okay. Okay, now we still have question. What's this? I squared. How to calculate this one? Right? You can see I1 equal to what? I1 equal to 200, right? Square plus I2 equal to 100, right? 100 to the center is 100, right? I3 is 0, right? Because the center is I3, center I3. I4, Y4 is 100, and I5 is 200. This we sum all that together, it is equal to 10 times, right? You know that? Okay, this is the program we solved stress. We solved connection was applied the moment and also the tension stress. Frankly, understand?
So, Lord Chief,
Yes.
so what's the number of F there?
F equal to 200. 200 kilonewtons.
kilonewton 수준이
So if you don't know, and if we can come back to this case. If F applied on here, right? If the F is equal to 200 kilonewtons, we move this one will also 200 kilonewtons, but it will be also produce a moment in this direction.
Yeah, but my
Let's
question
say it will be 200 kilonewtons pointed 80 millimeters, right? Okay.
the question was that if the small letter f FBT.
FT.
Yeah.
Okay, this is come from the code. I will get the value for you.
So I asked it the number.
You need the number, right?
우리가 뭐
Let's try and blame.
내가 똑똑이지
I don't think I'm right.
우리 옆에 뭐야
No, just somewhere.
I remember
Let us want to learn.
I showed you a FTB.
Yep.
Okay, you can find from the book. And also we have English values. For the boat, in the connection. Go to the virtual. This is translation value for the Chinese code. If you have time, you can read it. The data is come from here. Next time I will show fonts, the tables and show the, okay? So you can analyze it, I will find the tables for you. You can continue to think about this case. If you have any question, ask me. is sea level volt extension FTB equal to this date. Okay. But maybe you do not understand the Chinese English. Next class I will find the English tables for you. Okay. This is 170 for FTP. Okay. So this is both for one-way physical moment applied on here for the both condition.
Okay, Rashid. Can you do it that one?
Which one?
Yeah, that one, yeah.
This one again?
Yeah, with numbers so that you can understand well.
Okay, you can find this is for the errors. Okay. Traditional error we calculate in this state, right? Okay, I plot a new figures for you. This is M20, right? M20. And M20 and means the diameter is what? 20 millimeters, right? And we can calculate it for the transition, for the, this is 20 millimeters. The A will be equal to what? Point
These two.
220. It will be equal to 100. Is right? But it is we calculate use the effective E. Effective E. Effective E will be bigger than this size or smaller than this size. Effective E will be bigger than A or smaller than A.
Oh.
Yes. So the A is we cannot use this. So we normally we have a table to directly to check it. For M20, the effective E will be equal to okay. We can find it from the tables. And now we can come back to the date. When we use the directive traditional you use the areas, it will be to calculate to 53.3 kilonewtons, right? So, but do you remember the effective E equal to what? Right? And then we calculate this date point 170. It will be equal to these values.
Yes.
Right?
Yes.
So try to remember how to determine the AE. We have no rule. We just have a table. When do the calculations, if in the final exam, I will give the tables for you. But it is different for the weighting. Do you remember the weightings? The weighting size, right? Weighting size, HF, it depends you, right? When you use calculation, HE will be equal to 0.7 HF, right? This is the difference for that. For the effective areas, we have a table, and here our tables. We can check for the table because it is do some motivations. To decrease the effective areas. Clear? Okay. Now this class will focus on the moment case. Okay. We should come back for the last class. I remember give you homework. And I asked you we discuss in this class, right? You remember that?
Yeah.
Now, this is a very easy case. You will know how to calculate this case. Ziqiao? MVB, right? So, what's this? Why we should calculate the MVB? Why we should calculate? For this case, why we need to calculate the MVB? Okay, now I suppose that everyone know how to calculation. All right. So explain me why we use this date is equal to 15.
14.
Oh, 14. Why? You can find the T1 equal to 7. 7. T1 equal to 7. This plane equal to 7. And this plane equal to what? 16. So if you really know that, you can answer me this question, this equations. Try it.
Top one is bottom.
Why? 文琪 I not ask my boss, only ask you. The bearing complexity and the showing complexity, we get a single bolt complexity minimum. Right? You can find this for showing it's 100 bigger than 100. For bearing complexity is only 19. We choose this one. But when you can see if this is 14, the thickness T, right? Thickness T have different situation. Why would the thickness the T equal to 15, but 14? Because this is 7. How many situations I will single for you? One situation is 7, right? One situation is 7 plus 16, right? Another situation is only 16, right? 3. Next situation is 7 plus 16 plus 7, right? And then final situation is 7 plus 7. They have so many situations for the thickness. Why it is 14? For the calculate the bearing complexity. I try to ask you. I give you almost 1 week time to think about it.
It's the average.
Hmm?
14 is the average.
Okay, now I give you a trick. Now it's your job. Come here to write your value.
Well, it's gone.
I need a validate. Seven, 16, 7. Okay, come here.
Where are you going from?
Oh.
Hey, bro. Let me hear the drink.
The question.
Here. I need volunteers to explain.
Yeah. The question. I mean the.
7 plus 7, 14.
No, I think other parts everyone is no.
Yes.
So we just need only here. So I leave it out, figure it out for you to think about it. No? Some.
Yeah. Well,
Okay, I will explain for you.
Leave in yourself, exit.
I try to explain for you, for everyone, okay? So this is showing 3 trillion. I finish it. Fourth. Right? We think about first things we think about which one for the bearing complexity, which part will be destroyed. For the bearing capacities, you can see here will be tension this one, right? And another side, this one will be tension this one, right? The first time phase 2 here, and then this one will, right? So they choose we should opposite 2 situations. One situation is we suppose that this part is destroyed, right? Only destroyed this part, existing. Right? Another situation, we need to focus the direction. This is 7, this is 7. On the left. So 7 plus 7. Only these 2 situations. So this is 14, this is 16. Right? Now we calculate the bearing capacities. Normally, we will choose the smaller one, right? The smaller one may be more close to the dangerous, right? So, these areas point to the F, C, B, right? The areas equal to T, point there. Point, this is zoom T, sum T, point to the diameters, right? Diameter. We calculated the centers. Right? So, ZB. This is a seam. For example, we suppose this is 20, right? This is a seam. For example, it is 170. But this is depends you. Depends you. You can choose this one. But this one should be bigger than 14, right? We should find a smaller one to get this date performance. So we should use 14. Know that? Remember, it is not a situation for the case. The only we should follow in the direction of the force. Which one is choose interface in the direction? Clear?
But the other one, you had 5 situations.
Yes, other situation. This 7 is totally wrong. There is no reason because these 2 surfaces is together to have the force. Okay. Because if only 2 planes, you can leave the 7, right? But you have 3 planes. The force, one will apply a force in this part. Another 2 force will be to help sure this 2 force, right? Sure this force, and they should be appear together. Okay. So this should be wrong. 7 plus 16 is also should be wrong because this is 2 different interface, right? 2 and opposite directions. 1, 2, 3, 4. And 7 plus 16 plus 7 is also still wrong.
Good.
Right? So if you write this situation, you have a point. You have a point. But that means you understand this case. But for 15, this one 100% points. You will get 100. This one you will get 80.
And then 15 you get 90.
Huh? Because you know how to find the interface, but you choose a bigger values, right? If you choose that 16. Clear? Clear? Okay, so we get the minimum bolt values, now we can calculate the number of the bolt, right? Number of the bolt. And then we can check the strength of the plant. Okay, I see some students have a question about this one. Until to here, you all know, right? We have the total force, we have minimum force. The minimum number of the bolt equal should be 5.3, right? We can choose 6 is reasonable. Now, why we do this calculation?
By choosing 6 means that you are round off, right?
Not round off. Not round off.
The one that is.
Yeah, that's not round off, I understand, because it doesn't mean 5. But why did you bring 6, not 5? Sorry. Why did you choose 6 and not 5?
For safety.
Okay, since 5 is dangerous, you can see found if 500 over the 5, right? It will get 100 value, right? 100 compare this data. You issue the data should this is maximum data. If you choose 5, it will be bigger than this data. It's dangerous. Now, why here we should also do the calculation to check the strength is enough. What that means? This is the plant for the plant. Do you know? The plant.
Makes sense.
Okay, you should get the bolt design is finished. Now we check the altogether is right or not right. We should putting this one. This is bolt. This is plan. We choose this one, this side to check because we have 3 bolts, 3 parts will be empty, right? Three parts is empty. And the thickness is 16. This is the B equal to the B equal to 240, right? And we should calculate this surface. This surface, the strength of this surface is not strong enough. Okay, class over. We will discuss in the next class.